All right, guys, we're still on 5.6 review. I'm going to hit part 2, starting with number 6. Okay. I actually think I will do this one on here because I have a little bit of room. No, right here. Okay, perfect. Now, most important thing that I needed to identify is that this is the graph of f prime. Okay? Now, when I am going forward, meaning I'm taking the derivative of that, what I like to do is I'm going to start with where all my slopes are 0. So see how you guys, there's a slope right there of 0? That means that's going to cross at 0. There's a slope at 0 there. That means that's going to cross at 0. And there's a slope at 0 there. That means that's going to cross at 0. Okay? Now, to the left of that, these are positive slopes. All right? Which means they are big numbers. These are negative slopes, which means they are small numbers. And then positive slopes going down to negative slopes. Okay? So I think that's about what my f double prime is going to look like. Let's see here. Oh, there we go. Nope. Try and pull this. Take a look here. Number 6. And let's see. Okay. Now, let's actually analyze this part a little bit closer. All right, so this isn't actually a 0 slope. This is an undefined slope. And so kind of what's happening here, you guys, is if the slope is undefined at that point, it could be a jump, it could be a hole or something. So this is actually going to go here as I get positive and more positive slopes. And then at some point, it's going to jump. Now, this slope right here looks like it goes down 3 over 1. Down 3 over 1 is the slope for all those. So at negative 3, I would go to there. Okay? To that. To that endpoint. All right. Okay, now I'm going to go backwards. Let me see here. We're going to go to f of x. Well, the way I'm going to do that is I am going to do a couple of sine line graphs. So let me just move this second derivative out of the way for just a minute. Okay. And now check it out, right? The first derivative is 0 at 0 and 3 and 5. And this is closed at 5. Okay, and it's below the axis above. All right? So this goes decreasing, increasing, increasing. Okay, for my second derivative, it's the slopes of the first derivative. That's where the slope is 0. That's where the slope is 0. And at 4, that's where the slope is like undefined. Okay, and it goes up to 5. Well, look, these are positive slopes, negative slopes, positive slopes, negative slopes. And so it goes like this, concave up, down, down. All right? So let's see if we can sketch this here. Now it has to give me some kind of a starting point. So it did tell me to start at 0, 0. Now to the left of that, you guys, it's decreasing concave down. Or sorry, decreasing concave up is what that looks like. Okay, and then at 3, it looks like there's like a flat part. Because what it's going to do is it's going to increase and then go flat and then increase some more. But here's how the concavity goes. It changes at 1 and 3. So it goes, let's see, concave up to 1 and then down. And then between 3 and 4, it changes concave up and then down. Okay? So these ones are a bit tricky, but like sketching them back and forth, you want to make sure you're able to do that. Perfect. All right. Find the dimensions of a rectangle with maximum area inscribed under the curve as shown. Okay, you guys, if I start at 0, 0 and I go over x and up y, the area of this curve is actually 2xy because it's base times height. And if this is y, my area is going to be 2x times negative x squared plus 12. which is negative 2x to the third plus 24x. Okay, if I factor this out, well, actually first, sorry. Let me take a derivative of that. The derivative would be negative 6x squared plus 24. If I factor that out, I get negative 6 and then x squared minus 4, which gives me x plus 2, x minus 2. So x needs to be negative 2 or positive 2. Now I'm actually going to pick the positive 2 because I want to use that side of the graph, okay? When I do test points into here, I end up getting, if I plug in like a negative, okay, so I'm going to use positive 2. If I plug in like 0, I get a plus. If I plug in a 3, I get a minus. Okay, so this goes increasing, decreasing. So the way that I maximize my rectangle is when x equals 2, and when x equals 2, if I look right here, y equals negative 4 plus 12, y equals 8. So that's the dimensions of the area with max is x is 2, y is 8. Oh, I'm so sorry. The dimensions of this guy, x is 2 and y is 8, but the dimensions of the circle, because the bottom is 2x. So it is when x is 2 and y is 8, but the dimensions are 4 by 8. Okay? All right. Let's check out number 9. Two positive numbers. I'm going to go ahead and use, I'll do it right here, x and y. And it says the second is the reciprocal of the first. So x equals 1 over y. Find the two numbers so that their sum, x plus y, is a minimum. All right. Okay, cool. Well, this is already solved for x, so I'll go ahead and plug it in right there. So I have 1 over y plus y as my sum that I have to minimize. All right. Well, if I take the derivative of that, remember that 1 over y is y to the negative 1. So it's negative y to the negative 2, negative 1 over y squared plus 1. If I set that equal to 0, 1 equals 1 over y squared. So y squared equals 1. So y equals plus or minus 1. Okay? And it has to be two positive numbers. So y would have to be positive 1. And so if I plug that in over here, x would also have to be positive 1. Okay? And again, we can just test it and make sure as we do our testing into the first derivative. If it's like the number 0, well, I can't use 0 actually. If it's 1/2, 1 divided by 1/2 squared is 2. So negative 2 plus 1 is negative. And if I plug in the number 2, negative 1/4 plus 1 is positive. Okay? So their sum would be a minimum at the 0.11. All right, let's look at number 10. Make a little space here. Okay, a rancher plants a fence in 3 sides of a rectangular pasture with the 4th side being his rock cliff. He has 1,200 yards. Well, guys, that's going to be the perimeter, right? So 2x plus y is 1,200. We're trying to maximize the area, and the area of this is xy. Let me go ahead and solve this for y. It's like the same process every single time, yeah? Y is 1,200 minus 2x. Let me take that, plug it in. X times 1,200 minus 2x, or the area can be 1,200x minus 2x squared. My derivative for that is 1,200 minus 4x. And if I set that equal to 0, I get x is 300. Okay? Can I test if that is a maximum or a minimum? Well, if I plug into here, if I plug in something like 1, that's going to be a big positive number. If I plug in something like 1,000, that's going to be a big negative number. So it is maximized, okay, when x is 300 and y is 1,200 minus 2 times 300. So y is 600. And the actual max area is 300 times 600, which is 180000. yards squared. Okay? So these all just kind of follow the same exact pattern, you know? All right, great. Let's look at a couple more questions for this part. Let's see. Let's look at number 11. Now, again, one of the things that's huge in this chapter is looking at the graph of the derivative. Make that a little bit smaller. Okay, that's good. So this is, you guys, this is the graph of the derivative. All right? Okay. Let's go ahead and make my sign line graphs because I really don't like to do anything without my sign line graph. So my first derivative sign line graph, h prime hits 0 at -3, -1, and 3. Okay? When I plug it in, that's above the axis, below the axis, it still stays below the axis, above the axis. Okay? My second derivative, which remember is the slope of the first derivative, so it's going to change at -2, -1. It's all 0 between 0 and 2. Okay, and this one goes like this. All right, so my slopes are decreasing, so that's negative. Then they're increasing. Then they're decreasing. Then there's 0. You can like just kind of write like that, 0 or something. And then they are increasing. All right. You can write a 0. You can write, a lot of times we'll just like to be very clear, like write the word 0 or whatever. All right. Now we're going to really work on justifying our answer on these questions, okay? The answer for letter A, where is h decreasing? Well, it's on the interval -3 to 3, here to here. And the reason is because the derivative is negative, less than 0. You can write derivative negative, you can write less than or equal to 0 or whatever. Where do I have a relative max? Okay, I got to draw this real quick. Up, down, down. Oh. Okay, it has a relative max at x equals -3 because h prime changes from positive to negative. All right, nice. Oh, shoot. It said, where's that relative min? +3. My bad. From negative to positive. Okay. Part C. Where is h concave up? So it's concave up because, I should put on the interval first. On the interval -2 to -1 and 2 to infinity. Okay. I'll probably just use parentheses on all of these. Boop. All right. And that's because the second derivative is positive. But remember, we can't use that because it didn't give me the second derivative. It gave me the first derivative. So what I'm going to use is I'm going to say because the first derivative is increasing, which means the same thing as the second derivative is positive. Okay. All right. Where am I at? D. At what h values does it have a point of inflection? So point of inflection at x equals -2, -1. And that's it. Because this is not a point of inflection because it changes from negative to 0, which it has to change concavity to be a point of inflection. This is also not a point of inflection because it changes from 0 slope to a positive. So those are not points of inflection. And the reason is because you could say it like this, h prime changes increasing to decreasing or decreasing to increasing. Okay? Where is it increasing concave down? Okay, it's increasing up to -3 and concave down. So -infinity to -3. And then that's it. Nowhere else. Okay, why? Well, because h prime is increasing means greater than or equal to 0. And concave down means decreasing. So it's positive and decreasing. Okay. On what interval is h decreasing and linear? Look, if there's no concavity, it's linear. So it is linear from 0 to 2, but it's actually only increasing. Oh, it's increasing above 3. It's decreasing 0 to 2. Yeah, that works. So 0 to 2, because h prime is negative and like 0. But how do I write that? I can't say h double prime is 0, so I have to say the slope of h prime is 0. Okay? Whew. Find f prime of 2.5. All right, cool. And find that limit. Okay, so let's see. Now I'm going to go back up here for g and h. Okay, for g, it says if f of x is 3h prime squared plus 4x to the third. So it wants me to find f prime of x, and then I'm going to plug in negative 2.5. Okay, so if I bring that down in front, this will be 6h prime to the first, and then it'll be times the derivative of the inside, which is h double prime, and then this is going to be 12x squared. Okay? Now, if I'm evaluating this at negative 2.5, that's like right here. Okay? Now look, this is negative 2, negative 3. The slope goes over 1, up 3. So the slope of that is like negative 1/3. And, oh shoot, at negative 2.5, I think it would be at be halfway down, negative 1.5. So the y value would be negative 1.5. The slope would be negative 3. And then it's 12 times 2.5 squared. The reason it says you can use a calculator is just to multiply that stuff out, but if it's an FRQ, we can just leave it like that anyways. And then the last one says, okay, find the limit as x approaches negative 3 of h prime over x squared minus 9. Well, if I plug in negative 3 like we usually do with limits, okay, at negative 3, h prime is, what am I going to, at negative 3? Yeah. X approaches, oh yeah, negative 3. H prime is 0, and 9 minus 9 is 0. So it goes to 0 over 0, so I'm going to do L'Hopital's. So I'm going to do the limit as x approaches negative 3 of h double prime over 2x. H double prime at that point is negative 1/3, and then 2 times negative 3. So a negative divided by negative is a positive, and then that's going to be 1 over 3 times 3 times 2. So it's a positive 1 over, well, let's see. Hold on. It's 1/3 divided by, so times 2 times 3. So that'll be a positive 2. What am I doing? Hold on. H double prime of negative 3. Oh, the slope is not negative 1/3, you guys. It's negative 3. Why did I write it like that? It's negative 3 over 2 times negative 3, which is going to give me 1/2. Whew, that was a rough one. All right. Dang. All right, let's call that good for part 2 of the video.